Saturn Launch Vehicle Film Report number 36 combines the former separate reports on the Saturn 1B and the Saturn 5 programs. It covers progress during the period April, May, and June 1968. With delivery of the instrument unit by Super Guppy Aircraft on April 11th, all elements of the 5th Saturn 1B flight vehicle, designated SA-205, had arrived at the Kennedy Space Center from the contractor production plants. SIU-205 was shipped from the IBM facility at Huntsville, Alabama. The second, or S-4B stage for SA-205 had arrived at KSC on the same airplane 3 days earlier from the McDonnell Douglas Corporation's Sacramento Test Center in California. The first, or S-1B stage for SA-205 had been delivered by ship from Chrysler Michoud, New Orleans, late last quarter. Erection of the vehicle, which is scheduled to launch the first manned Apollo spacecraft flight late this year, was begun on April 15th and completed 3 days later. Spillage of a small amount of a hypergol oxidizer, nitrogen tetroxide, by technicians during a facility checkout of the spacecraft propellant loading system on April 21st necessitated removal of the IU and forward skirt of the S-4B stage to allow a detailed inspection for corrosion. Only very minor damage was revealed, and corrective actions were taken. During a neutralization flushing operation, some of the oxidizer was washed onto the vehicle's S-1B stage, necessitating replacement of a fin and several other first-stage components. The IU and S-4B forward skirt were re-erected on May 11th, and at the end of the quarter, SA-205 pre-launch preparations were continuing on schedule. At the Marshall Space Flight Center, prior to acceptance static testing of the S-1B-11 stage in April, LOX pump shaft seals, both lip and bellows types, were installed in the stage's H1 engines to determine the best fix for a LOX leakage problem, which last quarter had caused termination of an engine stability test by fire detection sensors after only 3 seconds. A successful short duration, 35 seconds, static test of S-1B-11 was conducted on April 9th. Inspection of LOX seals following the initial test resulted in a decision to install bellows-type seals on all engines for the long-duration firing, 145 seconds, which was conducted on April 23rd. Later inspection revealed no abnormal chipping or wear. Bellows-type seals will now be installed on all S-1B stages. S-1B-5 seals will be replaced on the launch pad at KSC. Previously qualified LOX sensors had been installed in S-1B-11 before the acceptance firings. Designed to provide additional safety for manned flights, these sensors will shut down engines prior to liftoff in case of a LOX seal failure. S-1B-11 was returned to Michoud from Marshall on May 11th, and post-static modification and repairs are underway, scheduled for completion in late July. S-1B-12, the last S-1B scheduled for static firing, arrived at Marshall from Michoud on May 4th for acceptance testing in July. S-1B-12 is the last of the 12 S-1B stages authorized in the Marshall Center's first order with the Chrysler Corporation. Fabrication work on subsystems for the follow-on contract, S-1B stages 13 through 16, was in progress at Michoud throughout the report period. Post-storage re-verification checkout of S-1B-7, a series of hydraulic, pneumatic, and electrical systems tests, was virtually complete at Michoud in late June. The checkout was to ensure that the stage is still in flight-ready condition. S-1B stages 6, 8, 9, and 10 remained in storage at Michoud. A new type of enclosure for housing stages in storage was successfully demonstrated this quarter, and in July, S-1B-8 will become the first stage to be moved into one of the enclosures. Other stages will be prepared for similar storage as schedules allow. Manufactured at MSFC, the plastic enclosures will be air-conditioned to maintain the proper temperature and humidity environment. Saturn 1B second or S4B stages 206, 208, and 209 remained in storage at McDonnell Douglas, Sacto during the quarter, as did stages 210 and 211 at the contractor's Huntington Beach facility. In mid-August, 208 and 209 are slated to be moved into the first 2 of 8 long-term storage plastic containers, now being manufactured at McDonnell Douglas. Other stages will follow as schedules permit. S4B-212 completed Apollo modifications in April and was placed in temporary storage awaiting headquarters approval to initiate orbital workshop mods. Modification work begun on S4B-207 at Sacto last quarter is continuing, with completion due in August. Saturn 1B instrument units 206, 7, 8, and 9 remained in storage at IBM's Huntsville facility during the report period. Special storage stands were installed in the storage area to allow the stacking of up to 6 IUs at any one time for long-term safekeeping. SIU-209 was the first to be placed into one of the new storage stands in early June. Structural segments for SIU-211 have been removed from storage and hardware diverted to use in a dynamic test unit at the Manned Spacecraft Center, Houston. Fabrication of an additional set of segments is planned for 211. Subsystems manufacturing continues for SIU-212. Highlight of the Saturn V program for the report period was the launching of the second Saturn V flight vehicle, designated AS-502, from Launch Complex 39 of the Kennedy Space Center on April 4th. After a flawless final countdown, the vehicle lifted off smoothly from Pad A at exactly 7 a.m. Eastern Standard Time. AS-502 served as launch vehicle for the Apollo 6 mission, an unmanned flight to qualify the Saturn V for future manned flights. First stage performance was as programmed, except for the occurrence at T+100 seconds of a longitudinal vibration phenomenon referred to as the pogo effect, which continued for approximately 40 seconds. At 2 minutes 23 seconds into the mission, the S1C stage's center engine cut off as programmed, and at 2:29, the 4 outboard engines cut off. The S1C engines burned for 148 seconds, only 1 second longer than planned. Second stage separation and ignition were satisfactory, and second stage performance was as programmed until T+215 seconds, when the stage's number 2 engine performance started to degrade. Degradation continued until T+412 seconds, when the engine prematurely shut down. This was followed within 2 seconds by premature cutoff of engine number 3. The remaining 3 engines burned for about 59 seconds longer than programmed to partially compensate for the early cutoff of the other 2 engines. S4B stage separation and ignition occurred as scheduled, and the stage met all operational requirements during its first burn of 170 seconds. Stage shutoff and orbital coast performance were also satisfactory, except for a pressure decay in the helium gas system. Stage restart procedure was normal up to and including ignition command, but the J2 engine failed to restart. A detailed analysis of the major anomalies encountered during the AS-502 mission was initiated immediately after the flight. Although some 80% of the 502 mission was considered successfully achieved, the other 20% occupied the concerted attention of NASA and industry engineers throughout the remainder of the period, seeking causes and corrections of the problems. The pogo effect, which occurred during first stage burn, is an up and down motion caused by the self-induced engine and propulsion system vibration frequencies coupling with the vibrational frequencies of the vehicle structure, resulting in a closed loop, ever-increasing oscillatory system. Engineers studied 3 possible fixes for the pogo effect in the S1C stage in an effort to alter the vibration frequencies of the propulsive system. If the pogo effect should become severe enough, it could prevent astronauts from functioning adequately or cause failure of the vehicle structure. The three fixes under consideration included addition of a helium-filled accumulator to the F-1 engine's LOX propulsion system feed line to act as a shock absorber, helium injection into the LOX propulsion system through a port on existing LOX suction line inlets, and gaseous oxygen injection at the LOX turbopump inlet aimed at changing the engine's natural frequencies. Static firing tests of F-1 engines incorporating these fixes were underway by the Marshall Center and by the F-1 developer, Rocketdyne Division of North American Rockwell, at the Edwards Test Site in California. Extensive tests and evaluations, coupled with a math model analysis, are expected to verify the corrective action necessary for the pogo fix. J2 engine failure tests have adequately demonstrated the failure mode of AS502's S2 and S4B stages as a rupture of fuel lines feeding the J2 engine igniters. Readout of 502 flight data had indicated this failure mode. In the case of the S2 stage, the fuel line rupture resulted in a fire which caused the number 2 engine to shut down. In the S4B stage, it prevented the engine from reigniting. Electrical connections for engines number 2 and 3 of the S2 stage had been switched during modification. As a result, during flight, the oxidizer cutoff signal for the damaged engine number 2 was erroneously received by engine number 3. Improved designs for the ruptured fuel lines have been completed, and new lines are being manufactured. The lines are made of stainless steel tubing without the 3 flexible bellows sections believed to have weakened the former design. The new lines are being installed in all S2 and S4B stages. A special cryogenic loading test of the S4B 505 stage at Sacto was part of investigations by McDonnell Douglas and MSFC into the pressure decay problem in the S4B cold helium gas system during the AS502 flight. Although the pressure loss was not considered enough to preclude engine second burn, it was determined that some helium leakage did occur around certain mechanical connections. As a precautionary measure, Teflon-coated conoseals will replace the present uncoated seals, and additional torque check requirements will be placed on all S4B stages. The scheduled launch late this year of the third Saturn V flight vehicle, AS503, which was erected at KSC last quarter, is not expected to be adversely affected by the AS502 investigations. If all problem areas are resolved as anticipated, then a decision very likely will be made to man the Apollo spacecraft to be launched by 503. Consequently, the 503 vehicle was partially de-erected early this quarter, and the S2 stage was returned to the Mississippi Test Facility for cryogenic testing required for man rating. Selected guidance components of the instrument unit were pulled and returned to IBM Huntsville for modification to support a manned mission. By the end of the quarter, these mods had been completed and the components delivered again to KSC. The S2-3 stage arrived at MTF on May 5th. Pre-test inspection of liquid hydrogen tank wells was completed 4 days later, and the stage was installed in the test on May 11th. The cryogenic proof test was successfully completed on June 9th. The stage was returned to KSC on June 27th and is expected to be restacked by late July. The S2 stage for the fourth Saturn V flight vehicle, AS504, arrived at KSC on May 15th from MTF. Delivery of the vehicle's S1C stage, S4B stage, and instrument unit will be delayed until late August based on KSC's need date. The S1C4 stage continued to undergo mod work by the contractor, Boeing-Michoud, during this report period. S1C5 has been placed in temporary storage with post-static checkout due early next quarter and shipment to KSC in late October. Cryogenic proof pressure testing of the S-25 stage was performed at MTF during this quarter, and shipment to KSC is due in October after completion of captive firing. In the three-part S-2 lightweight structural test program, during testing of the C structure at the Marshall Center, a failure occurred around the number 3 engine block area at 124% load condition of the 130% load which is required. The lower inner and outer cap rings of the thrust structure, as well as several stiffeners and rivets, were broken. Repair of the failed area of the C structure, which is made up of an S-24 type aft skirt, thrust cone, and center engine beam, is now underway. Analysis of failure has indicated a rivet material problem may exist. Flight fixes such as doublers to increase thickness will be installed next quarter, and the structure will then be retested. Another S-2 test item, the A structure, consisting of an S-24 type LOX tank, aft skirt, and cylinders 1 and 2, was installed in a test stand at Marshall in May, and testing is underway. Results so far are satisfactory. The tests will continue into the next quarter. Similar testing of the B structure, an S-24 type upper tank section, forward dome, and forward skirt, is also continuing at North American Rockwell's Santa Susana facility. Installation of the S-4B 504 LOX tank non-propulsive vent system, which will eliminate the necessity of going through specific vent schedules during the flight sequence, was accomplished this quarter at SACTO. The system had been installed on S-4B 503 at KSC last quarter and will later be installed on all S-4B stages. Deferred post-static checkout and modifications were completed on the S-4B5 stage in late May. The instrument unit for the 4th Saturn V flight vehicle underwent retrofit operations during the quarter at IBM Huntsville. SIU-505 completed systems testing and began mod kitting. Instrument units and stages for subsequent Saturn V flight vehicles are continuing in various phases of fabrication, assembly, checkout, and testing at the various NASA contractor facilities. The highlight of this report period, the launching of the second Saturn V flight vehicle, was indicative of both the progress achieved and the problems encountered in NASA's Saturn launch vehicle program. By the close of the quarter, NASA and industry's intensive search for solutions to those problems in both the Saturn V and the Saturn 1B was already bearing results which promised confidence in the success of the two flight vehicles now at KSC and of those to follow.